Hello, students. Today, our topic of discussion is sound. Whatever, I'm not going to the basic demonstration of what is sounds or not. I will start very particular. I will start from very particular thing that what is sound. Our first concern is what is sound. So let's talk about that. What is sound? So whenever I'm discussing that what is sound. See, you can hear my voice, right? This is also sound. When I will clap, that is also sound. So what is that? What is that actual thing that is producing sound? Means, what is the source of this sounds? So, well, let's discuss about this source of this sound. Sound source means how sound is produced. Actually, whenever the particle will do vibration, means we will see when the particle will do vibration, that time the sound will be produced. Means what? Suppose you are beating any drum, or you are clapping. When you are clapping, now that time the vibration due to your clapping produced sound. Means what? What is vibration? Vibration means to and fro motion of the particle. Vibration is what? To and fro motion of the particle. That means what? What is sound? Whenever we are discussing that when particle vibrates, that time sound will be produced. Well, that time means whenever we are beating anything or whenever any particle is vibrating, means vibration is happening. That time, this is the most important thing in the sound. Whenever vibration is happening, that time sound will be produced. Okay, well, so let's discuss some characteristic of vibration. And what is vibration? You can ask, so what is vibration? Vibration, it is nothing but to and fro or back and forth motion of particle. That means what? Whenever particle will do this kind of back and forth motion, that time vibration will be happening and that time sound will be produced. So that means what we can conclude? We can conclude that whenever particle will do the vibration, due to that vibration sound will be produced, and vibration is what? To and fro motion, or we can clearly say back and forth motion. Back and forth means back forth like this motion. That means vibration cause sound. That's it. Okay, well, that's sound. Now we will discuss characteristic of vibration. Let's discuss characteristic of vibration. First, I'm cutting this. So next our topic will be characteristics of vibration. Means what are the specific features of vibration? If we discuss about that, the first feature that we should discuss about the vibration, that is what? Amplitude. Amplitude of vibration. So, what is amplitude of vibration? So, to get to know about the amplitude of the vibration, first of all, you have to see this graph. Okay? Yeah. Now, we will draw a graph. Here, displacement. Here, time. Let's change. Okay. Now see. This is the maximum displacement. This is the maximum displacement. See, here this portion is the maximum displacement in the negative side, and this portion is the maximum displacement in the negative side. That means, what is amplitude? Whenever the particle will vibrate about the mean position of the that time that maximum displacement will be known to amplitude. I'm telling again. Means, first let me write what is amplitude. Amplitude of the vibration is whenever the particles, let me write, the particles will vibrate about the mean position, then the maximum displacement is known as amplitude. Again, restudy this thing. When the particle will vibrate about the mean position, then the maximum displacement about the mean position is known as amplitude. That means what? Let's see here. If I draw this graph, you will see here. If I draw this here like this, now the mean position, this is actually displacement d, this is time t. See, about the mean position, this is the maximum displacement. About the mean position, this is the maximum displacement. About the mean position, this is the maximum displacement. That means what? That means these things. Let me draw very clearly. That means whenever we are drawing that maximum displacement, maximum displacement means what? Maximum displacement means this one. This maximum displacement about the mean position is known to be what? That known to be amplitude. Now you might ask, okay, how can I get to know whose amplitude is greater, whose amplitude is lesser? Well, you must obviously get to know that about amplitude. Let's draw two graphs. Let us draw two graphs. First graph I'm drawing. First graph is like this. This. Second graph is like this. Okay. Let's draw. Here I'm drawing like this. Okay. And here I am drawing like this. Now one thing just you should observe. Here the maximum displacement and here the maximum displacement as compared to here the maximum displacement. For the first case, this is the case 1, this is the case 2. For the first case, the maximum displacement is greater than the second case where the maximum displacement is less in comparison with the case 1. That means where the amplitude is greater for the case 1. So amplitude will be greater for case 1. Why? Because maximum displacement is greater for case 1. So this is the concept about amplitude. That means what? Whenever the particle will do the maximum displacement about its main position, that is known to be amplitude. Okay? Whenever the particle will do the maximum displacement about its main position, that is known to be the amplitude of the vibration. Okay, that is the amplitude. Now let's talk about another very important feature of the vibration. That is what? Another important feature of this vibration is frequency. What is frequency? Let's talk about frequency. So now our point of discussion is frequency of vibration. Frequency of vibration. Now you might be asking, what's that? What is frequency of vibration? So let's discuss by the drawing. Now let's see. Here I am drawing two graphs. Okay. First graph, case 1. Second graph, case 2. Now just you observe carefully. And here you observe. Now you observe two things. First thing is that suppose here time t equals, along this axis time t, along this axis displacement d, and along this axis displacement d, along this axis time t. Now here you observe that had time t equals 1 second. First one cycle, second cycle, one half cycle, one full cycle, another half cycle. That means one full cycle and one half cycle has been covered at time t equals 1 second. But here at the same time, if we see at t equals 1 second, one full cycle, again one full cycle, again one half cycle, two full cycle, one half cycle has been captured. That means here at t equals 1 second, just one full cycle and one half cycle of the graph has been captured. But here at the second case, at the same time at t equals 1 second, more than one full cycle, two full cycle and one half cycle has been captured. That means what? Here number of vibration within few seconds, within 1 second. The number of vibration means what? That means here in this case, number of vibration in 1 second as comparatively here in this case number of vibration in 1 second is more. That means here in 1 second the number of vibration is as compared less than the number of vibration in 1 second in the second graph. So here frequency is more. Means what? If we just generalize this thing, if we just generalize, what we can write? Frequency of vibration is number of vibration or oscillation in 1 second is number of vibration or oscillation is 1 second in 1 second is known to be the frequency of the vibration, and number of vibration in 1 second means per second, suppose 5 number of vibration per second. That means what? That means what? The unit of the frequency will be, unit of the frequency will be 1 by second, or we can tell it will be hertz. So the unit of the frequency will be 1 by second or hertz. That means what? In 1 second, the number of vibration. Suppose you are a human, okay, and here you are a human, and you are vibrating your hand like this. You are vibrating your hand like this, but at the same time, a mosquito is vibrating. A mosquito. Let me draw. A mosquito is vibrating their hand. In 1 second, you are vibrating your hand 5 times. Suppose, maybe less than that. But similarly, 1 second, mosquito is vibrating their wings more than 5 times, maybe more than 100, nearly 100. Suppose. So whose vibration is more? Mosquito's vibration is more, because at the same time, in 1 second, you are vibrating your hand 5 times, but at the same time, mosquito is vibrating or oscillating their wings 100 times, so more than 5 times. That means whose frequency is more? Mosquito. So that's it, frequency, and it's the unit of the frequency will be hertz. Another important characteristic of the vibration is time period. What is that? Time period of oscillation. Time period of oscillation. Actually, time period of oscillation is inverse of frequency. Means time period is what? 1 by frequency. 1 by frequency. Means, what is it? Suppose you are doing. That means what? Let's discuss that. See. Here, I am drawing first 2 graphs. Again. Here one graph. Here another graph. Let's draw that. Now, here I am drawing these one. Suppose I am telling that suppose for the case 1, to complete one full oscillation, this graph is taking 5 seconds. Means for the first case, to complete one full oscillation, you are taking 5 seconds. But another case, to complete one full oscillation, you are taking 3 seconds. Remember, to complete one full oscillation, to complete one full oscillation, if one graph is taking 5 seconds, at the same time, to complete one full oscillation, another particle is taking 3 seconds. Now, whose time period is less? The second one. So, what is time period then? Time period is nothing but to complete one full oscillation, the time taken by a particle is known to be the time period. And what is the unit of time period? Unit of time period will be second. That's it. So time period is what? To complete one full oscillation, the time taken will be the time period. Okay. And the relation between time period and frequency is T equals 1 by F, or you can write frequency is 1 by time period. Time period equals 1 by frequency, or 1 by frequency equals time period. That's it. Now, Another next characteristic we'll study, that is what? That is characteristic of sound. Characteristic of sound. Now you might ask, what are the characteristic of sound? So first characteristic of the sound we will define here as loudness. The first characteristic was loudness. What is the loudness of the sound? So before discussing the thing, you should know loudness is nothing but it is proportional to loudness is proportional to the amplitude of the sound, proportional to the square of amplitude of the, or you might write loudness is proportional to the amplitude of the sound. That means what? That means if we write properly, loudness is the square. That means we can write that loudness is what? Loudness is proportional to the square of amplitude of the sound. Means what? Square of amplitude of sound means suppose you are doubling the amplitude. You are doubling the amplitude. Loudness will be quadrupled. Quadrupled means it will be 4 times. Means what? If you just double the amplitude, the loudness will be 4 times. That means how much you will increase the amplitude, loudness will be what? Loudness will be more. Means what? Suppose two of you are talking and one's amplitude is like this. Let me draw properly. Like this. This is the amplitude of someone and this is amplitude of someone. Now obviously this person has more loudness in comparison to this one. That means whose amplitude will be greater, his intensity of the sound will be greater, as well as his amplitude will be greater. So loudness is proportional to the square of amplitude, or specifically we have a logarithmic relation between loudness and amplitude. That is what logarithmic relation? Loudness equals 20 log 10 base amplitude. That's it. So in short, you will remember this thing: loudness is proportional to the square of the amplitude of the sound. Means how much you will be increasing the amplitude, loudness, the more louder sound will be you can hear, So that's it about loudness. Another important characteristic of sound that is more important to discuss, that is pitch of the sound. Pitch of the sound means what? Suppose we are telling girls and one is boys. Girl, boy. Now obviously you might know that when a girl is talking, always she will be high pitch voice. High pitch means not like that more louder, not like that. Means pitch is what? Pitch defines shrillness of the sound. You might ask her, what is shrillness? Shrillness means, I am telling, suppose you are beating the drum, and you are beating the suppose flute. You are not beating, you are suppose just blowing the flute. Or more interestingly, boys and girls. Boys, more in general, I'm telling in general, boys are having louder voice in comparison to girls. But if I'm telling about girls, girls are having high pitch voice in comparison to boys. Now you might ask, what is pitch? Pitch defines the shrillness. Shrillness means it defines the high frequency sound. High frequency sound, what's that? You might be knowing. See, first this is one graph, another this is one graph. Now listen carefully. When a girl will be saying something, her pitch means her frequency of the sound is more. But the same thing a boy is telling. See, in 1 second, 1, 2, 3. Means in 1 second the girls are capturing 3 cycles. Suppose in a vibration of sound, the girls are capturing more cycle of waves than the boys. This is high frequency sound, this is low frequency sound. That means this is high pitch sound, this is low pitch sound. That's it. That means pitch is nothing but frequency of sound, or more specifically if I say, pitch is nothing but shrillness of the sound. The another few more interesting topic of the sounds are quality of sound or timbre of sound. Now you might be asking, what is quality of sound? Suppose you are having same frequency, same loudness, but suppose violin and piano. I'm telling violin and piano. How can you distinguish if they are having same frequency, same loudness? The distinction between piano and violin can be done by the quality. Quality means, suppose for piano, the graph will be like this. Like this. The same loudness, same frequency, violin will be like this. Means quality is nothing but that will distinguish between the piano and violin, means that will distinguish between any voice. So this was our first part, that introduction to sound. We will come with our second part as soon as possible. Hope you have enjoyed the video. Okay, thank you.